Today we're going to be looking again at the PicoCalc. While it is tempting to storm ahead and make amendments to the hardware of our PicoCalc computer, for example replacing the Pico itself with a board with more memory or capabilities, there is still a great deal we can do with the out-of-the-box PicoCalc that needs to be covered. As we have in previous videos, we've connected our PicoCalc computer to the main Windows computer here using CoolTerm. This involves plugging in a USB cable to a USB-C type socket on the top of the Pico board here and connecting this to a USB port on your computer. What we're going to look at first of all is the option list command. Anything typed on our terminal window here will be transmitted to the PicoCalc. If we type in option list to our terminal, we get back a list of all the current options in force on MM-Basic. We can see, for example, the option auto run is turned on. This means when the PicoCalc is switched on, it will automatically run what's in the first slot. In this case, it's a program to display the Don't Panic image. We can also see the option for color code is on, which means when we go in to edit our basic programs, they are color coded on screen. And our display at the moment is going for 26 by 40. So it's worth speaking here about MM-Basic support for Flash and SD card file systems. We have two options on this computer. We have the A drive, which is the Flash, and we have the B drive, which is our SD card. We can see which one is currently the default one by using an MM.Info command. This tells us that we are currently connected to the A drive, which is the flash storage. There is a slight difference between the flash storage and the SD card. The file system on the SD card is not case sensitive, so it doesn't matter whether your file names are uppercase or lowercase. However, on the flash file system, this is case sensitive. This is the only difference between the two file systems. Long file or directory names are supported in addition to the old 8.3 format. The maximum file path length is 63 characters. So if we want to see what files are on our A drive, we merely have to type the word files. This will give us a list of all the files on the flash drive. So let's switch to our B drive, the SD card. So there are a list of all the files currently on our B drive, the SD card. We can of course create directories in either drive. If we want to create a directory, we can use the mkdir command. If we do mkdir and then in quotes the name of the folder we wish to create, it will have created this folder or directory on the B drive. And there we can see at the very top of the screen, there is our new test folder, our test directory. We can change into that directory by using the chdir command. If we do a files now, we'll see in our B test folder there are no subdirectories and no files. So if we want to go back to our root directory, a chdir with two dots will take us back one folder up the file system. If we wish to remove this test directory, we can use the rmdir command. And we'll see there is now no longer a folder called test. These commands, of course, can be used within your basic program. Let's create our test directory once more, and then we will attempt to rename the directory. There is our test new at the top of the screen. And if we want to rename this, we use the rename command. And if we do our files once more, we can see our test new folder is now been renamed to test. So there we have a small number of commands to create folders, delete folders, change into those folders as default, and rename them. You can of course nest a folder or directory inside another directory. However, if you remember, the maximum file path length is only 63 characters. And unlike some operating systems, when you're putting in a file path, it doesn't matter whether you use the / or / in paths. Either will work. When your PicoCalc starts up, the active drive, the default, is the A drive, the flash file system. As you will see from the output currently on screen, each file has a timestamp, the date and time when the file was created. However, one of the features of our PicoCalc is that it has no real-time clock. This is probably something we'd want to add on a hardware side to our PicoCalc, the ability to keep the clock running when the computer is switched off. However, one of the things you can do is to use the date $ command and the time $ command. If we type in print date $, we will get a date of the 1st of the 1st, 2000. You can of course set the date on the computer by making date $ equal to whatever the date in your current format is. Currently the time is telling us 24:06. This means the PicoCalc was booted up 24 minutes and 6 seconds ago. Again, we can set the time manually. And there we have the time now set. This, of course, is a little inconvenient if you're wanting to keep track of the times that files have been created or updated. However, this is one option you can have in your startup program when your PicoCalc boots up, something to prompt the user for the current date and time, until such times that we have a real-time clock running in the hardware. When it comes to accessing your file system within basic applications, up to 10 files can be simultaneously open, mixed between the A and the B drives. The need for having more than 10 files simultaneously open at the one time is fairly rare, depending on what the applications you create on your PicoCalc are intended to do. But it's a limitation that's well worth remembering. We used earlier the MM.Info command to return the current drive set file system, either A or B. There are a number of other commands we can actually use. If we look at files, we can see we're looking at our B drive. If we want to know how much free space we have on the B drive, we can use the MM.Info command to obtain that information. The free space option will allow us to find out how much space we have left on the drive. And there we have the amount of free space in bytes left on our drive. We can also use the disk size command to determine how big our SD card actually is. And comparing that to the free space, we can see we have used very little of this space. And if we do a simple calculation, we can see that we have 99% of our disk free. So there is plenty of room on our SD card for more data. We can also use the MM.Info to discover whether a file or folder is actually existing. If we have a look on our drive once more, we can see we have a test folder, the one we created earlier. In your application, you can test for the presence of that folder. This returns the value 1 to say that the test folder does exist. If we look for a folder we know does not exist, this will return a 0 to say the folder does not exist. We can do exactly the same using the file command. If we're looking for this out.bmp file here to see whether it exists or not, This will return 1 to say the file exists. If we look for a file that does not exist, it will of course return a 0. These commands can be used within your applications to look to see whether files or folders currently exist on the medium you're accessing. So this completes today's look at the file systems of the PicoCalc. Hopefully you'll find this information useful in your exploration of what the PicoCalc can actually do. But that's it for today. Thank you for watching.